So hello students. Today I'm going to discuss you with some basic definition on polynomials which is in Union 2. Okay. So I think you have all come across with polynomials in class 9, 10. So in general we are going to discuss it of a polynomial of degree n. So any expression of this form a0 plus a1x plus a2x squared plus dash dash plus a and x to the power n, where a is called any expression of this form, okay, where each ai's they are free from x and x is free from x, and this ai are nothing but they are called coefficients of x, and x here is called indeterminate. So any expression of this form is called a polynomial, and n here this n here x to the power n here stands for the positive integers of positive integers, and this x commutes with every ai, means commutes here means x ai is same as ai x, okay, for all I. So any expression of this form is called a polynomial, that is a0 plus a1x plus dash plus a and x to the power n, where ai's are free from x and they are called coefficients of x, and x is an indeterminate, is called a polynomial, and n is a positive integers. So we say here what is meant by polynomial over the set of integers. This stands for acute rational numbers, R stands for the set of real numbers, and C stands for the set of complex number. So fx here we usually denoted this polynomial expression as fx equal to a0 plus a1x plus dash dash plus a n x to the power n. This is a polynomial, and this is a polynomial over the set of integers, okay. Fx is called a polynomial over the set of integers if each ai belong to set, means if each of the coefficients of this polynomial belong to the set of integers. Now it is called a polynomial over the set of rational numbers if each of these coefficients belong to, if each ai belong to the set of rational numbers. So similarly with the polynomials over a set of real numbers or complex number, if each of these belong to the set of real number, then if each of the coefficient of this given polynomial belongs to the set of real numbers, so fx is called a polynomial over the set of real numbers. And also for the complex number, if each of the coefficients, that is a0, a1, a2 belong to complex number, then we call fx to be a polynomial over the set of complex number. So I hope it is clear to you what is meant by polynomial over the set of Q, R or C, means each of the polynomials belong to the set of rational numbers. Now we come to degree of polynomials. So if you have fx is this a0 plus a1x plus dash plus a and x to the power n, a0 plus fx, okay, is equal to this a0 plus a1x plus dash dash plus a and x to the power n, with a n here is not equal to 0, means it is not equal to 0, then the degree of the highest power of x, as you can see, the highest power of x is this, that is x to the power n. So this n here is called the degree of fx and is denoted by f of x. So by degree of polynomial we mean the degree of the highest power of x, and it is denoted by degree of f of x. So in this case with n here, n equal to a n different from 0, so we say that degree of this given polynomial to be n. For example, if you have this polynomial x to the power 5, 2x to the power 5 plus 5x cubed minus 2x squared plus 1 is equal to 0. This is a given polynomial. This is a polynomial. Fx here is this. Now what is the degree of, what is the highest power of x here? As you can see, it is x to the power 5. So 5 here is the highest power of x, so therefore degree of f of x here is equal to 5. Now by sum and product of polynomials, we consider fx to be equal to a naught plus a1x plus dash dash plus anx report n, and gx to be equal to b naught plus b1x plus dash dash plus bm x report m, with a and here different from 0, and here also bm is different from 0. Then the sum of this you just add here. Then f of fx plus g of x is defined to be the sum of these two polynomials, and it is equal to, where you add all the coefficients here. This one you add it with a naught plus b naught plus a1 plus b1 into x, take the common term x plus dash dash plus, since, and here we assume that suppose m is less than n, then there will be a term containing am here also if m is less than n. So there will be a term containing am, that is am x report n. So you that one am plus bm into x report n plus dash dash plus an x report n. So this will be defined as a sum of a naught plus b naught plus a1 plus b1 into x plus dash dash plus am plus bm into x report m plus dash 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 plus an x report n if n is greater than m. Now similarly, the product fx into gx is defined as where you multiply this given polynomial fx with each of this. So you will have a naught b naught will be the constant term. Now you multiply with this, you have a naught into b1x plus b naught into a1x. So that term which contain x, we will write it in one bracket. So we have here a naught b naught plus a naught b1 into x plus a1 b naught into x plus dash dash dash. The last term here will be an into bm x report n plus m by law of indices. So as you can see here, this term containing x both, so we can write it as a naught b naught plus a naught b1 plus a1 b naught into x plus dash dash plus an bm x report n plus m. So which can be rewrite as c naught plus c1x plus dash dash plus cn plus m x report n plus m. So the product is defined in this way, where c naught is equal to a naught b naught, c1 is a naught b1 plus a1 b2, c2 also will be a term which is the coefficient of x squared here dash dash, and an bm is replaced by cn plus n. Now we see that if each of these ai's and bi's belong to the set of this set of integers, if ai, bi belong to the set of integers, then this fx also will be a fx into gx, fx plus gx will also be a polynomial over the set of integers. Similarly, if each of ai, bi belong to the set of integers, the product fx into gx will also be a polynomial over the set of integers. So here we have, as you can see, in the case of addition of these properties of addition and multiplication of polynomials, if you have fx and gx, okay, then if you add them, fx plus gx, this is same as gx plus f of x, because this term here, like a naught b naught plus a1 b1 into x plus dash, is same as b naught plus a naught, since each of these belong to the set of integers, and this commute, and any elements which belong to the set of integers and the usual addition they commute, means a naught plus b naught is same as b naught a naught plus b1 plus a1 and so on. Okay, so therefore we have here the sum of two polynomials, addition of our polynomials satisfy the commutative law, means fx plus gx is same as gx plus fx. Similarly, fx, the product fx into gx also, which can be written as a naught b naught plus a naught b1 plus a1 b naught into x plus dash dash, is same as b naught a naught plus b naught a1 plus b1 a naught into x plus dash dash, which is same as gx into f of x. So this shows that product of two polynomials satisfy the commutative law. Similarly, with the associative law means f of x, g of x into hx are three polynomials or the set of integers or rational odd. Then these three polynomials satisfy the associative law, that is fx plus gx. You add first this plus hx, it is same as f of x plus the sum of the remaining two, that is gx plus h of x. Similarly, fx into gx with the product also satisfy the associative law, so which is equal to f of x into g of x into h of x. And the degree of f of x is equal to n. If you have degree of fx is equal to n, degree of g of x is equal to m, then degree of f of x plus g of x, that is the sum of the two polynomial, degree of the sum of polynomial, it depends on n. It will be equal to n if n is greater than equal to m, and it will be m if n is less than m. Now in case of the product, you have degree of f of x into g of x will always be equal to n plus m, which is equal to degree of f of x plus degree of g of x. Now the product of these two polynomial f of x into g of x will be equal to 0, which is called a zero polynomial. Then if this is equal to 0, then either f of x or g of x is equal to 0. I hope it is clear to you now, this basic definition and algebraic operations on the properties of addition and multiplication of polynomials. Okay. So the explanation on the next part, mean the division algorithm theorem, I'll explain it in the class.